Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto at nararapat. Kagandahang asal ang ipakita, ipadama ang pusong may malasakit. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Sakali mang tayo'y subukin ng unos, ating haharapin ng walang takot. Sasamahan ka ni Fernan at Dino, ang bagong barkada mo. Dito sa Fernandino Teens TV, boses mo ay mahalaga. Dito sa Fernandino Teens TV, edukasyon mo'y sigurado na. Dito sa Fernandino Teens TV, boses mo ay mahalaga. Dito sa Fernandino Teens TV, edukasyon mo'y sigurado na.
Fernandino Teens TV.
Anong ginagawa mo, Nan?
Heto, sinasagutan ko tong module ko sa science. Hindi ako makapag-concentrate. Ang init kapag tanghali.
Huwag kang mag-alala, Nan. Mabuti pa, magpamaypay ka na lang.
Paypay? May mas madaling paraan kaysa dyan. Gumamit ka ng electric fan.
Oo nga naman, Fer.
Paano nga ba gumagana ang mga electric fan? Mabuti na lang talaga at naimbento yung mga yan.
Para masagot ang katanungan mong yan, panoorin muna natin si Sir John Louie upang ipaliwanag sa atin ang mekanismo sa likod ng electric fan. Tara!
Let's G!
Good morning, Fernandino Teens. Welcome to another fun and exciting episode of Fernandino Teens TV Season 2. I am Sir John Louie L. Balingit, your science teacher lecturer for today. The second quarter is almost over, and I hope everyone is doing well. Before I present to you our topic, let us have a simple game. The title of the game is Where Do I Belong? During the pandemic, there is a rise in the use of technology. Different electronic devices are presented on the screen. I want you to sort them according to their capability to provide movement. Let's start with an electric fan. Is it capable of producing movement or not? Good job! Electric fan can produce movement. What about a washing machine? Correct, it can also produce movement. Next is the flashlight. Right, a flashlight cannot produce movement. Next is a blender. Can it facilitate movement or not? Good job! A blender can produce movement. Lastly, TV remote control. Can it produce movement or not? Excellent! A remote control cannot produce movement. Good job, Fernandino teens! In this game, we have classified that electric fan, washing machine, and blender can produce movement. But what makes it possible for these appliances to produce movement? To answer that question, let us decode this set of pictures through the game 4 Pics, 1 Word. Here are the set of pictures. You may type your answer in the comment section, Fernandino teens. The first letter is M. Next letter is O. Next is T. Next is O. And the last letter is R. Well done, Fernandino teens. The answer is motor. Basically, the electric motor is responsible for the movement because it converts electrical energy to mechanical energy. So how do motors and generators work? We will answer this question as we go through this episode. So prepare your ballpen, paper, and self-learning modules and join me as we discover the physics behind motors and generators. For this session, we will first identify the basic parts of motors and generators. Second, differentiate the types of electric motors. And third, enumerate applications of motors and generators in our daily lives. Majority of our appliances consist of motors. Motors and generators are essential for modern technology. Before we proceed to our discussion for motors and generators, let us have a review on the science principle that governs motors and generators, the electromagnetic induction. Before the year 1820, electricity and magnetism were viewed as two separate phenomena. So it was in the winter of 1820 when a Danish physicist and professor, Hans Christian Ørsted, demonstrated his discovery in electricity and magnetism in front of his classroom. He hooked up a coil of wire to a battery and passed a current through that coil of wire, and he observed that a compass needle next to the coil twitched whenever he did this. After several weeks of experimentation, Ørsted announced that electricity passing through a curved path produces a magnetic field. In 1831, Michael Faraday supported the concept of Christian Ørsted, and he revealed that magnetism can produce electricity. Michael Faraday made this discovery of electromagnetic induction with an experiment using two coils of wire wound around opposite sides of a ring of soft iron similar to the experiment setup shown. When the switch is closed, a current passes through the first coil and the iron ring becomes magnetized. The compass in the second coil deflects momentarily and returns immediately to its original position. The deflection of the compass is an indication that an electromotive force was induced, causing current to flow momentarily in the second coil. When you open the switch, the compass again deflects momentarily, but in the opposite direction. The closing and opening of the switch caused the magnetic field in the ring to change, to expand and collapse respectively. Faraday discovered that changes in a magnetic field could induce an electromotive force and current in a nearby circuit. The generation of an electromotive force and current by a changing magnetic field is called electromagnetic induction. To emphasize, electromagnetic induction is the production of an electromotive force across an electrical conductor in a changing magnetic field. Michael Faraday also designed the Faraday's law to accurately predict and measure how a magnetic field will interact with an electric circuit to produce an electromotive force. Previously, we have also learned that there are factors affecting the magnitude of the induced electromotive force. First, when a double loop of wire is used, the deflection on the voltmeter is twice as large as before. A triple loop induces 3 times the electromotive force and so on. This shows that the electromotive force is directly proportional to the number of turns in a coil. Second, the faster the wire is moved, the larger the deflection in the voltmeter. This indicates that the speed at which the conductor moves through the magnetic field also determines the magnitude of induced electromotive force. Third, the stronger the magnetic field of a magnet used, the larger the deflection in the voltmeter. This also indicates that the greater the strength of a magnet, the greater amount of induced electromotive force. The electromotive force can convert other forms of energy such as electrical energy into mechanical energy and vice versa. This law of physics allows us to produce electric motors and generators. Electric motor is a device that converts electrical energy into mechanical energy to produce a turning effect. On the other hand, a generator is a device that converts mechanical energy into electrical energy. When we return, we will identify the parts of electric motors and generators. So stay tuned, Fernandino Teens!
Ang Schools Division Office City of San Fernando, Pampanga ay kaisa ng Department of Education sa pagsasagawa ng mga proyekto at programa na tumutugon sa mga pangangailangan ng mga mag-aaral. Inilunsad ang Division Call Center for Tutors and Guidance Counselors upang magbigay ng educational at psychological assistance sa mga mag-aaral, magulang at stakeholders ng Division. Kaya, kung may nais kayong itanong tungkol sa pag-aaral, maaaring magpadala ng mensahe sa Division Call Center for Tutors and Guidance Counselors Facebook page o tumawag sa mga numero na makikita sa ibaba ng inyong screen tuwing Lunes hanggang Biyernes sa ganap na alas 8 ng umaga hanggang alas 6 ng gabi. Maaari rin kayong sumangguni sa ating guidance counselors na nagbibigay ng guidance and counseling services. Lahat ng inyong ibabahagi ay mananatiling confidential. Ang nasabing programa ay nagsisilbing daan upang malaman ang feedbacks ng stakeholders para matulungan ang ating divisyon na mapagbuti pa ang mga sumusunod na programa. Ano pang hinihintay ninyo? Tumawag na sa aming mga numero o bumisita na sa aming Facebook page at magpadala ng inyong mga katanungan.
Fernandino Teens TV.
Welcome back to Fernandino Teens TV Season 2. This is still Sir Louie, your science teacher lecturer today. Electric motors use electromagnets to convert electrical energy through magnetic energy into kinetic energy. An electric motor is all about magnets and magnetism. It uses an electromagnet and a magnet to create motion. This motion is produced due to attraction and repulsion between the magnets. We know that a magnet has 2 poles, the North Pole and South Pole. Always remember that the law of magnetism states that like poles repel and unlike poles attract. These attracting and repelling forces create rotational motion. Generally, motors have 3 main components responsible for rotation through attraction and repulsion: stator, rotor, and commutator. Stator is the stationary part of a motor made up of magnet. Rotor is the rotating part of a motor made up of electromagnet. Commutator is the part of the motor that ensures that the axle spins in one direction by changing the polarity of the electromagnet. To further understand, here are the parts of a motor: armature, It's an electromagnet made by coiling thin wire around 2 or more poles of a metal core. When electricity moves through the coils of the armature, it creates a magnetic field, and the rotor spins. Next is commutator. It is a pair of plates attached to the axle. These plates are connected to the two ends of the electromagnet's coil. The commutator swaps the contacts every half turn. Next is axle. Axle is a central shaft of an electric motor. The armature has an axle to hold it inside the body of the motor and let it rotate. Next is brushes. These are two metal plates and they are connected to the power source such as battery. The brushes press on the commutator. They keep contact with the commutator even though it is spinning around. The current flows in and out of the motor through the brushes. In other words, it means that the electricity flows first from the brushes, then to the commutator. Next is field magnet or permanent magnet. These are two permanent magnets attached to the motor's case. They produce a steady magnetic field so that the coil will turn when a current flows in it. The field magnet could be an electromagnet in large motors. However, permanent magnet is used in small motors to save power. So how do they even work? The motor is connected to a battery or any power supply. When the switch is closed, the current starts to flow and the coil in the armature becomes an electromagnet. In this case, the current is flowing counterclockwise in the top of the coil. This makes the top a north pole. This north pole is attracted to the south pole field magnet on the left. So, the top of the coil turns towards the left. You can also notice that the bottom of the coil is a south pole and is attracted to the north pole field magnet on the right. Once the coil gets to the upright position, there is no turning force on it because the electromagnet of the coil is lined up with the permanent magnets. If the current in the coil were constant, the coil would stop in this position. However, to keep it spinning, the commutator breaks contact in this position. So, the current stops for an instant. But the momentum of the coil keeps it going and the contacts are reconnected. So, the side of the coil that used to be a south pole is now a north pole. The commutator will keep swapping the contacts every half turn or when the coil is in the upright position. In this way, the motor keeps spinning. The job of the commutator is to reverse the electric current in the coil each time the coil rotates 180 degrees. Keep in mind that a motor rotates due to the attraction and repulsion between the electromagnet armature and the stationary field magnet stator. Although motors and generators have opposite function, they share the same components in general. Here is a motor generator model. It has an armature, which is made up of coil of copper wire and metal core. It also has commutator, axle, brushes, and field magnet. Let us observe what will happen if we connect the terminals of brushes to a power source. We will insert the negative wire to the negative probe. Then try to close the probe so that it will become stable. Then next is the negative wire, or rather positive wire, to the positive probe. Now, plug in the adapter to the power source. What have you observed, Fernandino teens? Excellent! The armature rotated as we connect the terminals to the power source. It is because the armature became a temporary magnet with the presence of electricity. As the armature serves as an electromagnet, it will be repelled and attracted by the field magnet, or stator, producing a rotational motion. Now, without connecting the model to the power source, we will try to light up this LED bulb. This model will now be used as a generator. Since generators converts mechanical energy to electrical energy, we are required to manually rotate this setup. Try to observe the LED bulb as I try to rotate the armature or rotor as fast as I can. What have you observed, Fernandino teens? Correct. We were able to light up the LED even though it is not connected to any power source. Amazing, right? You have also observed how changing magnetic field can produce electricity using the device generator. This same principle works on various electric power plants to generate electricity. For example, in hydroelectric power plants, the turbines connected to rotors are being turned by the flow of water. This creates changes in magnetic field, which will cause the production of electricity. When we get back, we will try to make our own simple electric motor using the materials commonly found at home. Stay tuned and we will be right back here at Fernandino Teens TV Season 2.
Maya po oras kaya kayo, Fernandinos. Ako pala ay Elwin Arl Serrano ng City Tourism Office ng Siyudad San Fernando. Ngayong bulan na ini, pagmasusyantaya ang National Heritage Month, nating temang Victory and Humanity, Upholding Filipino Heritage and Identity. Kambena nini, metong karang aktibidades na ng siyudad, apin ng launching ng bayong Heritage Passport. Yung Heritage Passport, apin ng metong karing proyekto ng kaya katamong siyudad, yung pamanamuna ng Mayor Edwin D. Santiago. Anong nuka rin makalagelangan ding eganagan ng heritage sites, heritage structures, naakit tamo kin kay katamong heritage district. Makakayado din kini, ding importansya da ding mapil na tradisyon kay ni syudad, kalupa na ning pamangawang parol, ang po yung pamangalesa. May aw siyang heritage passport, uling atin kang dapat gawan, anong nukaran puntalan mo lading at yung passport, at saka ka mag-selfie. Kay ba't kanta, palto making tourism office, at mamiyalang sticker ka rin eganagan ng apuntulan mong lugar. At timong may ngari ang tutong passport. Balo mingeni, panahon na ini, etamo makain bisa lumal, uli na ng COVID-19 pandemic. Kaya naman kimbanwa ngayon ni, agkatan ko lading bikers tamo, edad 18 hanggang 50, imbis na lumaot kayo po, di na nyo lang dita ka oras di kaya katamong heritage structures kaya ni syudad. Anya naman karing mumunang 50 bikers ang makayari kaya katamong heritage passport, midinan lang premyong only San Fernando loot bag. Inggawan nyo mo bakanta makapag-register, munta kayo mismo opisina na ng City Tourism, ng munisipyo, at saka kayo magdalang metong valid ID. Kabinan ng kaya kayong heritage passport, ating makasipit ang instruction nung nano pa ing dapat gawan. Anya naman ka rin hanggang kapadyakin, nanano ko pa, tara na!
Fernandino Teens TV.
Welcome back to Fernandino Teens TV Season 2. Before the break, we discussed the basic parts of a motor. Let us continue our meaningful discussion. After the discovery of Hans Christian Ørsted in 1820 that electricity can produce magnetism, Michael Faraday revealed that magnetism can produce electricity in 1831. To prove this, Faraday created the first electric generator. This electric generator is now known as Faraday's disc, which can produce a small amount of DC voltage. Generators have two types, the DC generator and the AC generator. DC generator is a rotating loop in a magnetic field which produces current that fluctuates in value but does not change direction. The current produced is called pulsating direct current. On the other hand, AC generator is a rotating loop in a magnetic field which produces current that fluctuates in value and changes direction every half rotation of the loop. This current is known as alternating current. A year after the invention of generator, William Sturgeon, a British electrical engineer, had built the first electric motor and invented the commutator in 1832. Do you also want to make your own electric motor, Fernandino teens? In making your own simple electric motor, you can use the following materials since they can be easily found at home: copper wire, battery, magnet, safety pin, and electrical tape. Just a reminder, if you want to try this activity at home, do this with caution and with the supervision of an adult. Let us watch my friend Sir JL as he makes his own simple electric motor. Hi there! For this day, we will make our own simple electric motor using the materials commonly found at home. I already have my copper wire, this size battery, magnet, safety pins, electrical tape, and a marker or any cylinder that can be used to coil the wire. And optional, you can use scissors to cut the copper wire and sandpaper just to remove the insulation of the copper wire. First, we will tightly wrap the wire around any cylindrical object such as marker at least 5 times. Leave at least 3 cm of the wire on each end. You may use scissors to cut the copper wire. Second, slide the coil out of the marker. Third, wrap each loose end of the wire around the coil a few times to make it stable. Then point the terminals away from each other. Fourth, you may ask an adult to remove the insulation of the wire using a knife, or in my case, I will use a sandpaper. Use an electrical tape to attach the heads of safety pins to the terminals of the battery. Six, put the magnet on top of the battery setup. 7. Insert the terminals of the coil to the holes of the safety pins. If your coil doesn't move on its own, give it a tap and observe if it will continuously spin. Now you know how to make your own simple electric motor. Keep in mind that there are also two types of electric motor: DC motor and AC motor. The type of motor that we have made is a DC motor. DC motor uses direct current as an input. On the other hand, the AC motor uses alternating current, and they are known for their increased power output and efficiency. Now, let us proceed to our game entitled Text Twist. You are required to decode the jumbled letters to identify the word that is being described. You may type your answers in the comment section. Are you ready, Fernandino Teens? Let the game begin. A device that converts electrical energy into mechanical energy. Let us reveal the answer. Great! The answer is motor. Ready your fingers, Fernandino Teens. Here is the second round. An electromagnet part of a motor made by coiling thin wire around two or more poles of a metal core. Let us reveal the answer. Good job! The answer is armature. Here is the third round. A device that converts mechanical energy into electrical energy. Let us reveal the answer. Excellent! The answer is generator. Next round. A type of motor that utilizes direct current as an electrical input. Let us reveal the answer. Correct. The answer is DC motor. Here is the last round, Fernandino Teens. A kind of magnet where the magnetic field is created by an electric current. Let us reveal the answer. Right. The answer is electromagnet. Well done, Fernandino Teens. When we return, we will try to discover how motors affect our lives. That and more when Fernandino Teens TV Season 2 returns.
Hindi lamang sa larangan ng pangkabuhayan apektado ang maraming pamilyang Pilipino, kundi maging sa larangan ng pagkatuto ng bawat batang Pilipino. Inilunsad ng siyudad ng San Fernando ang programang Nurturing Environment and System for Thriving or NEST, isang education community pantry na naglalayon para sa isang malawakang pagtulong, pagtantabay at paggabay na ang focus ay ang makapagbigay ng tulong at suporta sa ating mga mag-aaral sa pamamagitan ng pagbibigay ng educational needs gaya na lamang ng school supplies, tutorial sessions, study tips, at iba pang mga pamamaraan na mas lalong makatutulong sa pag-angat ng ating edukasyon. Dahil hindi hadlang ang pandemya sa magandang kinabukasang naghihintay sa ating mga mag-aaral. Sino-sino nga ba ang mga kalahok sa programang ito? Sa pagtutulungan ng ating school administrators, guro, magulang, at iba pang mga miyembro ng ating komunidad gaya ng barangay officials at sangguniang kabataan ay siguradong magiging mas matagumpay ang programang ito. Paano nga ba ang magiging proseso ng naturang programa? Una, magkakaroon tayo ng isang Facebook group, ang Pampanga High School NEST Education Community Pantry na pangungunahan ng Educational Pantry Coordinator. Ang mga magulang, tagapangalaga at mga guro ay ia-add ng ating educational pantry members sa Facebook group na ito. Sa page na ito, maaaring i-post ng mga magulang at tagapangalaga o sino mang miyembro ng educational pantry ang kanilang mga kahilingan o requests. Kailangan ding ilagay ang pangalan ng mag-aaral, grade, at section para sa mas agarang aksyon. Oo nga pala, hindi lang requests ang pwedeng i-post. Pwede ring mag-post ang mga nais magbigay ng tulong o mga gustong mag-donate. Sabi nga nila, sharing is caring. Tandaan na ang Facebook group na ito ay pribado at posts na may kaugnayan lamang sa page na ito ang maaaprobahan. Mayroon din palang Google Form na ipamamahagi kung saan maaari nating isumite ang ating requests o kahilingan. Paano naman ang mga walang internet access sa bahay? Huwag mangamba dahil merong mga nakalaang drop boxes ang ating paaralan na kung saan maaaring ihulog ng mga magulang at tagapangalaga ang kanilang requests. Sa mga nais namang mag-donate ng school supplies, maaaring ilagay ang mga ito sa tabi ng drop boxes. Maaari ring mag-donate ng mga kagamitan o cash donation kaakibat ang pagsusumite ng deed of donation form. Pangalawa, mahalaga ang ugnayan ng mga guro at ng mga magulang o tagapangalaga sa programang ito. Gamit ang video calls o chats ay ipahahayag ng mga guro ang adhikain ng programang ito sa mga magulang o tagapangalaga. Maaari ring gawin ang orientation na ito ng face-to-face kasabay ng schedule ng kuhanan ng mga module. Gaya ng nabanggit, hindi lamang mga bagay ang maaaring i-donate. Pwede ring mag-conduct ng tutorial session, study tips, at iba pang mga kagamitan sa pagkatuto gaya ng mga aklat o kaya ay gadgets. Ikatlo, ang requested needs ng ating mga magulang o tagapangalaga ay ililista ng ating NEST focal person. Ang mga coordinator naman ang mag-aayos ng mga ito. Ang advisors ng ating mga mag-aaral, guidance counselor, at iba pang mga guro ay ipaaalam sa ating mga magulang at tagapangalaga ang petsa at oras ng pamimigay ng requested needs na gaganapin sa paaralan. Sabi nga nila, it takes a village to raise a child. Kaya naman aktibo at iba yung pakikilahok ang inaasahan sa pagsasanib puwersa ng paaralan at barangay na siyang tutukoy sa pangangailangan ng bawat Fernandinong mag-aaral at kikilos upang matugunan ito sa tulong at suporta rin ng mga miyembro ng komunidad. Isang malawakang komunidad para sa isang produktibong educational community pantry ay tiyak na lilikha ng iba yung pagkilos upang maging mas magaan at madali ang pagkatuto ng bawat kabataang Fernandino. Kaya naman tandaan, magbigay ayon sa kakayahan, kumuha ayon sa pangangailangan.
Fernandino Teens TV.
Hello, Fernandino Teens! You are still watching Fernandino Teens TV Season 2. Motors have a variety of uses in our society. Can you identify at least 5 devices that have motor? Type your answers in the comment section. Which do you prefer when going to the mall's upper floors, Fernandino Teens? Stairs or elevator? What about during hot sunny weather? Do you prefer fan or electric fan? What about when washing your clothes? Do you prefer to wash it with a machine or just by your hands? The invention of motor is a world-changing event that greatly and irrevocably affected the way we live our lives. It is evident in forms of transportation we take to get from one place to another. From cars, seafaring ships, and the airplanes flying the skies above us. Motors have also influenced how we live at home, especially when it comes to doing house chores. Here are some of surprising examples of appliances and devices that use electric motor technology, or at least those you may not have thought at first. Number 1. Computer. Computers do in fact have motors, even if at first glance it doesn't seem to have any moving parts. The motors have to do with its hard disk drives. It spins the plotters in a drive and read the data stored on them. Also, the cooling fans that blow the hot air away from the inside of the unit requires motor to spin. Number 2. Refrigerator. Another common household appliance, the refrigerator needs small motors to operate its compressor. This compresses the refrigerant chemical into a liquid to create the cold temperature that helps preserve fresh goods. Air conditioners work in a similar fashion. Number 3. Microwave oven. There is also a motor in the microwave oven, a kitchen appliance used to heat leftovers and thaw out frozen goods. It is mainly in the turntable mechanism that slowly rotates your food as the microwave itself starts the heating process. Number 4. Vacuum cleaner. This ever-reliable device requires a powerful suction motor to suck in dust and dirt off floors and carpets. Some models even allow for the flow of air to be reversed. This allows you to use your cleaner as a blower in a hurry. Number 5. Smartphone. Yes, that pocket-sized computer in your bag or pocket does have a couple of motors inside it too. One of them is easy to find, the one that gives your phone its vibration. There's also one in your phone's camera lens to help it focus, zoom, as well as to stabilize the image. Number 6. Electric toothbrush. This automated wonder that lets us clean our teeth quickly and thoroughly also has a micromotor in it. This makes the bristle head vibrate and spin at the touch of a button. Number 7. Printer. This essential device for making modules and assignments also has motor in it that makes it possible for the paper to be rolled out of the printer. Number 8. Nebulizer. This lifesaver device also uses motor to pump air out of the compressor to produce fine spray of liquid for inhaling medical drug. There you have it, 8 of the most common household appliances and devices that use motors. Some quite obvious, others not overly so, especially if you've never really had experience in taking them apart. But it really does go to show just how much the advent of the electric motors has changed the landscape of modern convenience. Generators are also essential in our life. They are being used to provide sufficient electricity. To see how generators work in electricity generation, let us watch this video.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly you can see, right? Well, the truth is there's a lot more to generating and delivering electrical power than you've probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states. Transporting electricity from the power plant to your home is an entirely different process. Current technology cannot cost-effectively store large amounts of electricity, so significant challenges exist when it comes to transferring that electricity across long distances. Just enough electricity has to be generated to meet demand at all times and be transmitted through power lines to reach your light switch. Too much or too little power can crash the transmission system and cause a blackout. That's why a complex mix of logistics, management, and infrastructure is needed to transmit electricity from power generators to consumers. Enter the electricity grid, also known as simply the grid. The North American electricity grid is actually made of 4 large grid systems: the Western grid, the Eastern grid, the Texas grid, and a grid covering the Canadian province of Quebec. These independent regional networks of power plants and transmission lines carry electric energy at high voltage within their area to local utilities. There are very limited links between the 4 grids, which means electricity generated from a wind turbine in West Texas cannot reach an apartment building in New York City. For electricity to move through one of the 4 grids, its voltage must first be increased by a device called a transformer. Then the electricity can travel long distances across high-voltage transmission lines. These high-voltage lines are generally strung between giant metal towers. They stretch for miles from power plants to local substations in each neighborhood. You've probably seen substations along the side of the road and wonder what they do. Well, their job is stepping down electric voltages from levels as high as 765,000 volts closer to the 110 volts you use in your home. The electricity from the power line on your street passes through another transformer, which steps down the voltage once more, and then it travels along the line into your house. From there, the electricity enters your breaker box, and it is then distributed to light sockets and outlets. All you have to do is flip a switch. So, as you can see, from the raw materials to the power lines on your street, there's so much more to the electricity ecosystem than meets the eye.
Let us now reflect on our discussion for today. It has now been more than 2 years since the outbreak of the COVID-19 pandemic, which has profoundly changed our lives. Right now, everyone is going through a difficult time in their lives. During this time of uncertainty, keep in mind that if there is always a device to transform one energy to another, there is always a God to transform one lives for the better. To conclude our session for today, let us evaluate how much you have learned. Do not worry, it is just a multiple choice type of test. Just type your answers in the comment section. Let us start with the first item. Number 1. Which of the following refers to a device that converts electrical energy to mechanical energy? Letter A, generator. Letter B, motor. Letter C, transformer. Letter D, voltmeter. Type your answer, Fernandino teens. Very good. The correct answer is letter B. Number 2. In the presence of power interruption, which device should be used to produce electrical energy? Letter A, generator. Letter B, motor. Letter C, transformer. And letter D, voltmeter. Type your answer, Fernandino teens. Excellent! The correct answer is letter A. Number 3. Which part of a motor is characterized by a fixed magnet attached to the motor's case? Letter A, armature. Letter B, axle. Letter C, electromagnet. Letter D, stator. Type your answer, Fernandino teens. Great! The correct answer is letter D. Number 4. Which type of electric motor is present in electric fans, giving it higher efficiency? Letter A, AC motor. Letter B, DC motor. Letter C, servo motor. Letter D, stepper motor. Type your answer, Fernandino teens. Right! The correct answer is letter B. Last but not the least, number 5. Which of the following devices doesn't have a motor? Letter A, DVD player. Letter B, drill gun. Letter C, wall clock. Letter D, rice cooker. Type your answer, Fernandino teens. The correct answer is letter D. And that ends my presentation. These are the references that I use in this presentation. This has been Sir John Louie L. Balingit. Thank you and keep safe, everyone.
Ayan, Fer, naipaliwanag na ni Sir ang konsepto ng motor at generator.
Oo nga, mas naiintindihan ko na ngayon kung papaano gumagana ang electric fan at ito pala ay sa pamamagitan ng motor.
Tama, ipinaliwanag din niya ang kaibahan ng motor sa generator. Nagbigay din siya ng mga halimbawa at aplikasyon nito.
Marami na naman tayong natutuhan ngayon.
Kaya naman,
Maraming salamat, sir.
isa na namang panibagong kaalaman ang ating natunghayan, Fernandino teens.
Samahan niyo ulit kami dito lang sa Fernandino
Teens
TV,
Season 2.
kung saan ang kabataang Fernandino ay angat sa angking talim.
Bagong umaga, yakapin mo ang bagong pag-asa. Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat akin, magkaakbay nating lulutasin. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto at nararapat, kagandahang asal ang